Hello folks, this is Leah Bonasake from Master Lab Systems. Okay, today we'll be looking at Dockerizing a Java Spring Boot microservice with Docker Compose. Okay, so let's look at the agenda for today. So, for example, basically we'll start by looking at the introduction to the solution that we need to be containerizing it. We're using Docker Compose. Also look at why Dockerize a microservice, Dockerizing the ledger service, add the transfer service, connecting the services together, and using Docker Compose to deploy those to Docker, and scaling and improving from future. Okay, let's look at the introduction to the solution now. So, for example, this microservice solution contains two services, which is the ledger service and the transfer service. So the ledger service maintains account balances and transactions, while the transfer service handles money transfers and communicates with the ledger service, of which essentially this means the transfer service cannot function without having a connection to the ledger service. Both services are built on Java 17 plus Springboot 3, and they are designed to use REST APIs for communication. Okay. So now let's look at why Dockerize a microservice. Okay, again, the benefits of Dockerizing a microservice give us a consistency, meaning it runs the same everywhere. So, such as dev, test, and production environments. Isolation. Each service is packaged with its own dependencies, which makes it much easier to avoid conflicts of having two services sharing the same dependencies. Okay. So scalability. So each service can be scaled independently as both services are stateless, meaning one, if the ledger service is too busy and or the transfer service is too busy for handling main transfer, so we can scale that one independently. Okay. Looking at the portability now. So deploy on any cloud or on-prem server. So meaning this can be easily deployed on cloud or on-premise server. So meaning on your local machine or on your local on-premises server, you can do the whole deployment, or rather deploy on any cloud-based service. Okay, let's look at Dockerizing the services now. So again, since I said we have two services that needs to be Dockerized, so meaning each service will have its own Docker file, and then we'll just deploy those parallel using the Docker Compose. Okay. So for example, now connecting the two services. So by default, the transfer service uses localhost, for example, port 8081, while the ledger service, while the transfer service will use port 8080 on the front end. Okay. So meaning the transfer service will use port 8081 when connecting to the ledger service. However, they are using what now, or service names. For example, if you see here on the string this URL, so the ledger services URL, it's not longer localhost port 8081, however, but it uses its own service name, such as ledger service -colon 8081. Okay, that's only inside Docker, of course. Okay, so now let's go ahead, folks, and look at how we can create our Docker Compose. So for example, if you are not familiar with the composite way, this is how it would look like running this service in the these services in a containerized environment using Docker Compose. So this is how it would look like. However, now of course this is not too much fancy or too much formatted well, so which is what we should just be copying to our IDE. But of course, if you require the source code, then I can provide it to you. But of course, now let's go ahead and look at how we can do this solution. So again, I have my own Docker desktop running in my machine. Currently, I have only about so much of images, but of course, as you can see, we don't have anything for ledger service or transfer service, which is what we should be creating. So these are old and none of them are running. As you can see, they are all exited. So if now we go again to our IDE, which is in this case I'm using my IDE, which is IntelliJ. So if now again I try to hit out docker ps-a, which should list out all my, or maybe let's just do docker ps, which basically should list out all my running images. So currently you should see nothing because there's no image that's running, and we don't have, as you can see, it's just blank, nothing. Okay, so now let's look at our Docker Compose file. So okay, as I said, this is the structure for our application that we need to be containerizing it using Docker Compose. So now what we just need is just to have a Docker Compose file outside of the services so they can be able to do a proper referencing. Okay, for example, now take this is like this. We have a ledger service that's responsible for managing and writing all the ledger transfers, and then we have the transfer service that's responsible for doing or for moving money between two accounts or making transfers essentially. So now ledger service, inside the ledger service, it needs to have its own Docker file, which is what we are having there in this case. So it has its own Docker file. Same goes for, if we take a look at the transfer service, it also have its own Docker file. So the Docker Compose now will essentially just invoke these Docker files and do the build and deploy our applications to our Docker desktop. Okay, so now for example, if now I were to give you a log to each of these Docker files for these services, for example, if we start with looking at the Docker file for ledger service, I'm just going to close this one just to avoid any confusion. So for example, this is now the Docker file for the ledger service. So of course it just does nothing much, but it does a build, copy dependencies, copy source codes, it runs the build, and it creates a snapshot and starts the application from port 8081. So this is the whole Docker file for a ledger service. So now let's look at the Docker file for the transfer service. So if we go to the transfer service now, we should have something like this. So for example, this one, what it does the basic on its own as well. It does the basic, meaning the build, copy source file, copy source code, does the build, package the application, and expose it to 8080 so we can be able to access it on the browser. But again, this one, we just need to realize something. As I said earlier, the transfer service cannot function without having the ledger service, to be up, for example, since it communicates and does all the processing to the ledger service. So the transfer service now have to be told that, okay, or have to be set that the connection to the ledger service, it's on 8081. So when it does its build, meaning on the Docker Compose, when the Docker Compose does the build for the transfer service, it will come in here just to invoke this section or just this line. So again, meaning this now, it tells that Docker that we have an environment variable, which is ledger service URL, and that's the environment variable URL for that. So meaning now, by doing this will mean now on runtime or on startup, the transfer service will be able to communicate to the ledger service due to this environment variable we have set it in on our, when we're unpacking our environment variables. Okay, so now that we have that in there, folks, so now what I'm just gonna do again, same goes with running. So again, when it runs, it will reference the ledger service URL, which is, again, it just calls that URL, which is what the ledger service is running on, again on port 8081. Okay, so now that we have both these Docker files for both of our services, so we can begin to look at our Docker Compose now. Okay, so I'm just going to close this again, so to ensure that we have a clean environment. So again, now we need to reference those each. So again, starting up, we have services. We are defining our services now. So again, ledger service, we need to specify where the build file is, meaning where the Docker file is. So again, as I said, the Docker file for that ledger service will rely in that path. So if you go to ledger service, you go to ledger service, again, it's the Docker file. So of course, putting this path, it makes sense, and also the ports it needs to use 8081, of course. So now moving on, let's look at now the transfer service. So same goes for transfer service. We just need to provide the proper referencing, so of the Docker file or the build file, as you may call it. So again, on the build, we need to specify the correct path where the build file relies on. And again, on ports, we are specifying the port for transfer service, which is 8080, and the environment. It's very important that it knows that the ledger service runs on, and the URL for the ledger service. Okay, so now that we have all of these folks in place, we can begin. Just gonna clear this. We can begin running again. You could do Docker Compose app, for example. If now I do ls, because of it's important that when you run this Docker Compose file, we are on the correct path where the projects are. Okay, for example, here it's possible that if you want to use this way, you can do Docker Compose app, of course, but in my case I like to just simply use the IntelliJ interfaces. It makes it easier even for referencing. So of course, as you can see, even just by hovering over, it shows you the command that it will execute, which is the Docker Compose app. Okay, so now if we click now this to execute this Docker Compose, let's now wait now, folks. These steps usually takes a bit of some time, but of course, once these services have been deployed successfully, we should see them in our Docker desktop. But of course, we can just give it them some time. It will probably take some time. Of course, if you haven't done it before, it does take a lot of while. But of course, if you have done it for some time or multiple times, as it will just reload your current existing data. Okay, so again, now we can verify seems to have finished and it has started the images. So I'm just going to verify that now from our Docker desktop. Okay, let's go and verify that. Okay, so now if we, okay, there it is. You can see, folks, we are getting a ledger system. Let's narrow it and see our services. Okay, as you can see, folks, and they are 1 minute ago created, meaning exactly because of we recently created them. So now it seems like both are running, ledger service and transfer service. Okay, so as you can see, folks, they are both running. Okay, transfer service on 8080 and the ledger service on 8081. So again, now we can attempt to test this by going to our Postman, probably do a healthy check or a healthy request to our ledger system or to our ledger service. So let's go ahead now. For example, now that we can see that both of our services are up and running. However, as I said, the transfer service, it dependent on the ledger service. So meaning here we will test it through Swagger. However, the ledger service doesn't have any Swagger schema. You can only use it through requests, through call requests or via Postman. So for example, now I have some queries for our application. So for example, now if I go to the healthy endpoint or the healthy endpoint, yes, so as you can see, it goes to 8081 ledger and health, meaning this request will definitely come to the service. So it needs to give us the status if it's up or down. So now if we go to our Postman just to do a basic test and send this request, wow, nice. As you can see, folks, it's up and running. So as we are getting 200 status code and the response, it's up. So now, meaning now we should be able to make these transfers. Okay, so again, let's go to our browser and attempt to use Swagger, for example. So if now I go to my local, and Swagger would mean it's going to 8080, localhost 8080. As you can see, this is it, folks. So both of these services are successfully able to connect to each other and are running. But to test the connection now to each other, we need to do what? We need to make some transfers from our transfer service. Since it will do the since it will, of course, uses the ledger service to write those transfers and to allow, because of the transfer service only responsible for moving money to between accounts or making transfers. But of course, as you can see, currently we need to create an account and put some initial balance. Then we can be able to use this side for transfers. Okay, again, the service that's responsible for doing that, it's basically what? It's the ledger service. So the transfer service cannot create an account, and it cannot create an account with an initial balance. So again, we require now to go back to our ledger service and start to create some accounts within initial balance. Then we can then be able to use the transfer service to make some transfers between those accounts. Then we can test the end-to-end connection. Okay, so if now we go to our first query, so this is how we are creating these accounts with an initial balance. For example, if now I put the initial balance to 3000 and it's going to what? Localhost 8081 and accounts. So meaning it's going again to hit what? To hit ledger service, which runs on 8081. So if now again we go there to create this account with an initial balance of 3000 rand. So let's send this query. Okay, as you can see, the account 1 was created with an initial balance of 3000 rand. Let's create another account and let's say, for instance, this one, it's gonna have 4000. Okay, and then we send that. Of course, we are getting an ID2 with a balance of 4000 rand. Let's do now one last bit of let's put this time 6000. Okay, and let's make that, as you can see, again we are getting an ID3 with a balance of 6000. So now we can start to initiate our transfers using the transfer service. Again, the transfer service cannot function on its own if the ledger service is down. So it's a must that the ledger service is up and running, so the transfers can be possible or can be successful. But of course, we'll do a test run of that. But for now, let's first go ahead to our Swagger and start to initiate a basic transfer using a transfer service that goes to our ledger service. Okay, I'm just gonna get okay, probably we can just use a batch transfer just to make it simpler. So as again, we're now going to be using now the transfer service to initiate these batch transfers. So if now we come in here, okay, not you, let's create this one. Okay, I'm just gonna provide a basic item key, probably test 1 2 3. Okay, so now for example, if we come in here, I'm just gonna paste the request body. So now this is what we are saying: from account 1 to account 2, transfer an amount of 100. From account 2 to account 3, transfer an amount of 50. From account 3 to account 1, transfer an amount of 75. Okay, so now we should be able to initiate these transfers and check the balances after. Again, the transfer service cannot check any balance, so it means that for us to verify if these transfers were successful, we can still use what the ledger service to check the balances again of these of these accounts ID that we created. So now if I execute this query, okay, let's verify. Sweet. As you can see, folks, all of our batch transfers are successful. As you can see, transfer ID, we got the ID and the status is success, and the transfer message is completed. All of those batch transfers we made. So now again, we can take one of the transfer ID just to get the status of it. So if, for example, now I were to copy this transfer ID and use this endpoint to verify the ID transfer state. So now this one will require for us to specify the transfer ID, which is the log, and let's execute. We should get the information related to that status ID, to that transfer ID now. Okay, so again, as you can see, the transfer that was made was from account 1 to account 2, and the amount was 100 rand, was 100, transfer ID and the status of success created, and the message transfer complete. So meaning the transfer service now is able to communicate with the ledger service and initiate these transfers. Again, let's go and verify that one last time to ensure that the transfer was success by checking the account balances from these 3 accounts created. So now again, to do that, we're required to go back to our ledger service. Since again I said initially the ledger service doesn't have an access to SOC, we can only use Qual or Postman. So again, as you can see, a request will go to ledger service because it's port 8081 and account. So now by doing this, we are an account number which is 1. So by passing the account number parameter will give us some information about these transfers, about these remaining balances for this account. So for example, now on account 1, let's say how much balance are they having after this transfer. As you can see, folks, the balance is no longer 3,000, but it is changed to a new amount, so meaning the transfer was successfully completed. So now if we check for account 2, as you can see again, the transfer was completed successfully due to the new balance. So if we check for account 3 now, okay, again we are getting 5.975, meaning the transfer was successful. Okay, so now again, let's say we wanted to do another transfer, but this time the ledger service is down, and see what we'll be getting. So to test that now, a transfer when the ledger service is down, so we should see, of course, now that the service is no longer, so we'll have to stop the backend, which is the ledger service, for a minute. So if now I were to stop this, so meaning now we shouldn't be able to make any transfer when we have stopped the ledger service. Okay, so as you can see, folks, it has exited, so meaning it's no longer running. The only thing that's running, it's what? It's the ledger service, it's the transfer service. So let's try to initiate another transfer when the ledger service is down and see what response will be given. Again, we can confirm that now that if we run this query again, right, okay, again, if we run this query again, because at first we were getting up as the status, but now let's check the health again and see. Now that it's down, we know that it's down, but let's check the status. Okay, as you can see, it could not send the request because of there's no connection going there. So that's why we are not getting anything. So again, you can try to do that, definitely not gonna get anything because of that endpoint is down or it's dropped. So let's go now and try to initiate another transfer just to do a test when the ledger service is down. So I'm just going to do cancel, close this, and open up our batch. So again, we just need to change and say maybe test 1 2 3 4 5, just so we don't make it. Okay, again I will still use the same amount to initiate this transfer. However, we know now we should not be able now due to the ledger service being down. So let's try to execute that and see what response we'll be getting this time. Okay, it's still loading. Okay. Look at what we are getting now, folks. The response now. Again, as you can see now, status it's failure. Message ledger service unavailable. Exactly, which is what we anticipated, that the ledger service now that it's no longer up and running, we shouldn't be able to initiate any transfers. So again, if we now were to test again, but of course we wouldn't because of the ledger service unavailable, so no transfers were initiated. So as you can see, folks, our microservices architecture was successfully dockerized using Docker Compose. So I think I will be ending here, folks. Again, if you have any questions or anything that you want to raise, I will be glad to answer those. Okay, so now if we go back to our slide, I'm just gonna ensure now that we are done. So please, folks, if you have any questions, you have any suggestions, please let me know. Comment from my comment section below. I'll be answering those. And again, please, if you feel this video is useful to you, please like and subscribe. Thank you, folks, for watching. Till next time. Cheers, peace.